take that off. All right, so this is about chemistry. So we talked about this already, but your body is made up of chemicals. That's why we study chemistry when we talk about the human body. So everything is composed of chemical elements, all forms of matter. And chemical elements are substances that cannot be split into other simpler things by chemical means. And they're given abbreviations, and you can see the abbreviations in a periodic table. Like carbon, for example, is a C. Nitrogen is an N. Our body, and in your book you have a periodic table, tells you that our body is mostly hydrogen, carbon, nitrogen, oxygen. We also have other elements in our body that are present in tinier amounts. So elements are composed of atoms, and an element like carbon is made up of carbon atoms, or oxygen is made up of oxygen atoms. In the nucleus, you have protons, which are positively charged, and neutrons, which don't have a charge. Those are in the nucleus, which means the center of the atom. Electrons surround the nucleus, and you can see a negative sign here. They have a negative charge. There's other terminology, but they're called shells, sometimes electron shells, sometimes they're called clouds, but they reside outside the nucleus. If this is the nucleus, my 8-ball, and inside here would be protons, neutrons, and around it, always constantly moving, are negatively charged electrons. Electrons, paper clips, very small. Their mass is about 1/2000th the size of a proton or a neutron. So in what we're going to do this class, we're going to count it like it has zero mass, zero, because it's so small. And you can see those are the electrons orbiting around the nucleus. And in this picture, the protons are represented with the red circles, and the neutrons with the blue circles, and electrons with the black circles. Protons are very large, and they're positively charged, like I said, but the number of protons in the nucleus, so 1, 2, 3, 4, 5, for example, or 1, 2, 3, 4, 5, 6, equals what's called the atomic number on the periodic table, and that determines what element it is. So if you look in your periodic table, in your textbook, all right, which is on page, turn on my thing, I don't know why this keeps turning off, B3 in your book here, and you look at any of the elements, like carbon, for example, a number above it is 5. That is its atomic number. And every atom of carbon has 6 protons in it. And that is how the periodic table is organized, based on the number of protons. So every atom of an element has a different number of protons, and that's called its atomic number. Neutrons are second largest, and you can also, like I said, find them in the nucleus. They have no charge, so they're neutral, but they add mass to that atom. Neutron number in an atom can vary, and when it does vary, they're called isotopes. For example, carbon, like we're talking about the carbon atom, its atomic number is 6, which means it has 6 protons. Carbon-12 also has 6 neutrons, thus giving that number 12. 6 plus 6 is 12. But carbon-14 has 2 extra neutrons in the nucleus. But it's still a carbon atom, it just has a different number of neutrons, which would then give it a different mass. Carbon-14 is used for carbon dating how old things are in the ground. We don't need to go over that, so I'm just going to delete Atomic number, like I said, is the number of protons. The mass number is the sum of the protons and the neutrons, and it's a whole number, the mass number. So like carbon 12 in that last example, 12 is its mass number, the number of protons plus the number of neutrons. Atomic mass, which you also see on the periodic table, that number at the bottom, you can see carbons there, 12.011, is the average mass of all naturally occurring isotopes. It's an average, so that's why it's not exactly a whole number. So that would be the number of protons plus the number of neutrons. It's about 12. Here is just numbers of some of the more important elements in your body and how many protons, neutrons, etc. they have. So hydrogen, it has an atomic number of 1. That would mean it has 1 proton, which we can see in its nucleus. Its mass number is 1 or 2, and its atomic number is 1, or atomic mass is 1. So it doesn't have any neutrons. And I should also state that the number of protons in an atom always equals the number of electrons, because atoms have no electrical charge. They're electrically neutral. So whatever the positive number is of like protons, it needs to equal the number of electrons. Here we have oxygen. Its atomic number is 8, so it has 8 protons. Atomic mass is 16. So 16 minus 8, it has 8 neutrons. And then if you count, it also has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So atoms have no charge. The number of protons equals the number of electrons. Ions, on the other hand, have a charge. Ions are atoms that have either kicked out an electron and thus becomes positively charged, or gains an electron, so now it has 2, to become negatively charged. Those are ions. Ions are electrically charged. And so here is a sodium atom. It kicks out an electron, because we'll talk about that in a little bit, but then it becomes, since it kicked out a negative charge, it becomes positive. So now it's a sodium ion. When atoms share electrons, they become a molecule. And molecular formulas show how molecules are orientated. So here we have H2O, when 2 hydrogens share electrons with an oxygen. That, of course, is water. Here is oxygen gas, O2. We can see 2 oxygen atoms are sharing 2 electrons here. So when you breathe in oxygen, you're not just breathing in the atom oxygen, you are breathing in oxygen gas, which is a molecule, O2. A free radical is an electrically charged atom or group of atoms, like you can see here, superoxide, it's unstable or has an unpaired electron in its outer shell. Those electrons like to pair together. So because it's unpaired, let's have one over there, it's unstable and highly reactive. The only way they can become stable is by either kicking an electron out or gaining one, and they want to do that. So they'll search and tear apart tissue, fat, as some of you discussed the other day, to do that until they're happy with their electrons matched up. Antioxidants inactivate those free radicals. Chemical bonds. They are what hold atoms together in a molecule. They bond, or they hold hands, bond. And they're forces of attraction. And the likelihood of one atom bonding with another atom all depends on the number of electrons that are in its outermost shell. So here we have a carbon atom. It has 2 electrons in its closest shell and then 4 in its outer. I should also say that to be happy, the outermost shell in most atoms needs 8 electrons. So carbon wants 4 more, and here we have hydrogen atoms that want 1 more. They each need 1 more to be happy. So they are a perfect pair. This hydrogen bonds with this electron. Here they share those electrons. Here they're sharing electrons. Here they're sharing electrons. Here they're sharing electrons to make the molecule methane gas. So these lines right here represent the bonds between the carbon and the hydrogen. Ionic bonds, so now we're getting into the types of bonds, is when an atom either kicks out an electron or gains an electron. It's called an ionic bond, thus producing ions, which are electrically charged, either positive or negatively charged. And then as a result of that, we have one that's positive and one that's negative. The positive ion, looks like a T, doesn't it? Is a cat ion. Notice the T. Positively charged ions. They have given up an electron, at least one or more. Anions have gained an electron and thus become negatively charged, also called electron acceptors. So here's a great example of an ionic bond, table salt. We have a sodium atom, and over here it has 1 lonely electron in its outer shell, and it wants to find a friend to bond with. Here we have chlorine that has 7 electrons in its outer shell, and it only needs 1 more to be happy. So they make a perfect pair. Sodium will kick out an electron, and chlorine will accept it. So now sodium atom becomes a sodium ion. Since it kicked out a negative electron, it's now positively charged, and chlorine accepted the negative or the electron, so now it's negative, and so it's called chloride. And together, positive attracts a negative, just like in magnets, and they make NaCl, which is table salt. And they kind of stack up on each other, just like you see here, which forms a crystal. Electrolytes. Table salt would be an example. When you put salt in water and stir it around, instead of being NaCl, it separates into sodium and chloride. Okay, those are electrolytes. Anything that ionizes in water, when you put that molecule or compound in water, it'll separate into sodium chloride, for example, that have electrical charges, which are called ionized. So when I say ionize in water, they become ions. Electrolytes dissolve in the body fluids in your body. That makes sense. And they're called electrolytes, like sodium, chloride, potassium, because they can actually conduct an electrical current in water. Covalent bonds are another type of bond. They don't kick out an electron or accept an electron. Instead, they share the electron. They can share 1 electron, as you can see represented by this line. They can share 2 electrons, which would be a double line, or they can share 3 electrons, which you can see here. These 2 nitrogen atoms are sharing 3 electrons. Covalent bonds are the strongest chemical bonds. Sharing is strong. You can watch that video on your own if you want. It's kind of funny. Covalent bonds, right here, these sharing bonds can either be non-polar or polar. And I used to think these terms were really confusing,